Hello, dear children, and welcome back to the class. Dear students, today we are going to learn about chapter number 4, Effects of Electric Current. The objective of the lesson are energy transfer in electric circuit, heating effects of electric current, magnetic effects of electric current. My dear children, we have learned in earlier standard about static electricity. We also perform a lot of experiments regarding negatively and positively charged objects. Why the positively and negatively charged particle get attracts towards each other. If the elements donate the electron, then it will carry the positive charges. Dear children, observe the diagram carefully. What do you observe in the diagram? Which effects of electric current do you find? My dear children, if you observe the diagram carefully, then we are able to conclude the electricity or electric current or electric energy get converted into the heat energy. Then heat energies get converted into the sound energy. Television is there. Heat energy or electric energy get converted into the light energy in the first picture. Second picture, we are able to see the fan. We are able to conclude the electric energy get converted into the mechanical energy. And in the third picture, we are able to conclude the electric energy get converted into the sound energy. Dear children, in the ninth class, you already studied the transformation of energy and the law of conservation of energy. Now, dear children, we are going to learn about energy transfer in an electric circuit. For this, we need the connecting wires, electric cells, electrical resistance, voltmeter, ammeter, and plug key. Connect the circuit as shown in the figure. After taking the components with proper values, measure the current, also measure the potential difference between the two ends of a resistor A and B. The potential at point A is higher than the potential at point B, as the point A is connected to the positive electrode of the cell and the point B to the negative electrode of the cell. If a charge Q flows from point A to point B, work VAB into Q has been done on Q. While going from point A to point B, from where does the energy come to this work? So, ninth class we studied the concept of work. So here, dear children, the source of energy is nothing but the cell. Cell acts as a source of energy. Cell provides the energy to the circuit. That's why the charge Q flow through the conducting wires to the resistors, where work VAB into Q is performed. If the charge Q flows from point A to point B in time t, the work is performed in time t. Then during that time, the energy VABQ is given to the resistor. What happens to this energy? This energy is received by the resistor and is converted into heat energy. The temperature of the resistor is increased. So, my dear children, P is equal to electrical power, and electrical power is nothing but the energy divided by time required. Energy that we already studied, VAB into Q upon D, that is equal to VAB into I, because Q upon D is equal to I. The source of energy, that is cell, gives in time t the energy P into T to the resistor. If I is the current flowing continuously through the circuit, the heat produced in the resistor will be H is equal to P into T. is equal to VAB into I into T. According to the Ohm's law you people were studied in the ninth class. What is mean by Ohm's law? What the Ohm's law states that Ohm's law explains the relationship between the electric current passing through the conductor and the potential difference between the two ends of a conductor. So VAB is equal to IR. H is equal to V square AB into T upon R. Similarly, H is equal to I into R into T. I into I means I square into RT. So H is equal to I square into R into T. This is nothing but the Joule's law of heating. Unit of electric power is nothing but the watt, because 1 volt into 1 ampere, potential difference we are measuring in volt and current we are measuring in ampere. So 1 volt is equal to 1 joule upon 1 coulomb, and 1 ampere is equal to 1 coulomb into 1 second is equal to 1 joule upon 1 second, that is watt. So unit of electrical power is watt. This is all about the electrical power. I hope so it is clear to you. Heating effect of electric current. When a resistor is connected in an electric circuit, heat is produced in it due to the current. This is known as heating effect of current. Equipment such as water boiler, electric cooker, electric bulb make use of heating effect of electric current. Electrical conductors having higher resistivity are used. For example, a coil made up of an alloy nickel is used in electric heater cooker as a resistor, while a tungsten wire is used in an electric bulb because of the current. This wire gets heated nearly 3400 degrees Celsius and emits light. The hot wire also radiates heat to a certain extent. Several times we hear or read about a building catching fire due to short circuit. Sometimes, if we switch on an equipment in our house, the electrical fuse wire melts and the electric supply shuts down. The home electrical connections consist of live, neutral and earth wire. In detail, 9th class we studied about this. The live and the neutral wires have potential difference of 220 volt. The earth is connected to the ground. Due to a fault in the equipment, or if the plastic coating of the live and the neutral wires gives way, the two wires come in contact with each other and a large current flows through it, producing heat. If any inflammable material such as wood, cloth, plastic exists around that place, it can catch fire. Fuse wire is used as a precautionary measure. We have already learned about the fuse wire in previous standard. As soon as high current flows in a circuit, fuse wire melts and breaks the circuit, and any mishap is avoided. This is all about the heating effect of electric current.
Effects of electric current. An electric current is created when electrons move through a conducting material such as a wire and is capable of generating heat and magnetic effects. Let's look at each of these in more detail. You've probably noticed that it is common for an electric bulb to heat up when it's lit. As electric current moves through a metal wire, such as a tiny coil in the center of the bulb, the atoms in the metal will acquire some energy. With this new energy, the atoms will vibrate more, causing the wire to become warmer. In this way, some of the electric current is converted to heat. This current-generated heat can be used to run many home appliances, including electric heaters, stove, and irons. Electric fuses are safety devices that help prevent damage to electrical circuits. If excess current passes through a fuse wire, it will overheat and melt, breaking the circuit and preventing excess electricity from running to the appliance. Now let's look at the magnetic effects of electric current. To do this, we'll need a small cardboard box and several feet of copper wire. Remove the lid from the box and then wind the wire around the box a few times. Connect the free ends of the wire to a regular battery and a switch so that a complete circuit is formed. Then place a compass inside the box so that it sits directly underneath the wound wire. Note the direction the compass needle is pointing and then move the switch to an on position. You will notice an immediate deflection of the needle. Once the current is switched off, the needle will swing back to its original position, proving that the electric current passing through the wire created a magnetic effect. The magnetism generated by an electric current is the principle behind electric bells and motors.